Okay, so we've solved linear absolute value equations. Now we're going to look at linear absolute value inequalities, just like we did with regular linear equations. We solved those. Then we did with regular linear equations, we solved inequalities. With the absolute value, it's a little trickier because there's two ways to do it. It depends on if you're greater than or less than. All right, so if I'm looking for the absolute value, all right, remember, we always start at where it's equal to the constant. So my function ax plus b absolute value is equal to k. And remember, there were two possible solutions if k is positive. So again, if k is positive, there's two places where my function equals that k value, on the positive side and on the negative side. And so it matters now which inequality I'm looking at. Am I looking at where my absolute value is bigger than that k value, which remember, k represents a horizontal line. So is my function bigger than my horizontal line k? Or is my function smaller than my horizontal line k? It's equal to k when it crosses. Right? So I either include k or I don't include k, whether or not I have equal to's or not equal to's. And so the picture, it's easy kind of to look at this visually. Right, so here's my graph where I've got my function ax plus b absolute value. So there's my v function, my absolute value function. And then if I have my k, my constant line where it crosses it twice. If I'm looking for the less than case, all right, so the first graph here is the less than case. And so this is sort of the breaking point, right? This is where the function equals k. If I'm less than k, I've got to be below it, right? My function values are below it. Well, it's below it in that little v part. Right, my function is less than k, right? The y values are smaller than k. Between the 0, where it crosses my x-axis, and then the k value. Right, that's what the answer would be. So if I'm looking for ax plus b less than k, well, it would land between whatever these two values are. Right, my x value would be less than that first s value, greater than that second one, right? That's where the answer would land. So again, these would be numbers, like it would be between -2 and 5, right? My function is less than the k value, and then if it had equal to, you would just do equal to's here, right? It would just include whatever those x, again, these would be x values, whatever those x values would be. So that's the less than case. So less than is going to give me a between answer. I'm going to be between my x values where it hits my function, where it intersects my function. All right, and then the other case, when it's the greater than case, so this is the greater than case, so b represents the greater than case. And so again, the horizontal line is where it's split, right? That's where it's equal, right? So my function is equal to the k value when it hits that line. And so it would be greater than the k value when it's above that line. And so the values where it's above it, and I didn't mean to shade everything in. All right, so again, the line's where it crosses. It's above that red line at the tails here, at the end, right? That's when it's above it. Right? So there's two pieces where my function above it. My function's above it here in this spot and here in this spot. It's equal at k. Between the k's, it's less than. That was the first example. And so when it's bigger than it, it's from k to infinity or from the negative k to negative infinity. And so there's two tails to it. I've got the tail shooting off to positive infinity, and I've got the tail shooting off to negative infinity. And so if my absolute value of ax plus b is bigger than k, right, I've got to be bigger than it, right? So my ends are what I'm looking at. My ends are when they're bigger. And so that there's two parts to it. There's when the ax plus b is greater than k. Right, that would be this tail end over here. And then there's when the ax plus b is less than the negative, right? That's the, again, going to negative infinity would be less than the negative version. And so there are two answers. X is going to be greater than whatever this s value is, or x is less than whatever that s1, right, the negative value is. Right, this would be the x is less than s1 side. This would be the x is greater than S1 side. And so the answers would shoot off to the infinities, right? I would be going from negative infinity, no, this would be the positive side, greater than. I would be going from that S2, that's an x value, to infinity, or from negative infinity to that second one, S1. Right, so there's two, and then if it's equality, you would just do an equal to. Alright, so an equal to, and then these would be brackets instead of parentheses. Okay, so there depends on what I'm looking for. If I'm looking for bigger than, it's the tails. There are two answers. I'm shooting off to infinity on one tail and shooting off to negative infinity on the other tail. If it's less than, I'm between. I'm between my two values where I intersect. Alright, and so it's the between case. And that's how we actually solve it. Alright, so how we solve linear absolute value inequalities, well, it depends on which one I'm asked to solve for. Alright, so if k is, and we're only going to look at k positive cases. So negative cases, remember, does not exist. So k is positive, is the only case that we can have. So it's positive. If I'm looking for when it's less than k, that would be the between case. And so we solve it using the compound inequality. We set it between the positive k and the negative k, right? I've got to be between the positive and the negative value. If it's bigger than k, I've got to be on the outside part, right? So I'm bigger, right? So I've got to be on the above part. And so that's the one that's going to the tail. So I'm bigger than the k value. And so when I set that up, my tails are shooting off to positive infinity and negative infinity. And so there's two equations I've got to set up. Alright, so I've got to have my x plus k has got to be less than the negative k value. And my ax plus b has got to be greater than the positive k value. So that should be a positive k value in there. I had a negative for some reason. So again, that has to be positive k. And it's the same with the equality. You just equal k or don't equal to k. So it'd be including k or not including k. And those are the applications. So we're going to get to solving those in the next section. So again, we have to split them into two outcomes. If it's less than k, it's the between case, right? Less than k, it's the between case. So I solve for the between. If it's greater than k, I've got to be greater than the line, and so it's got to be my tail. So one tail is going off to positive infinity, so I go positive k to positive infinity, so the positive is greater. And the negative's got to go off to negative infinity, and so when I set up the negative, it's got to be less than, because I'm shooting off to negative infinity. This one's shooting off to positive. That's kind of how I remember it. I want to be bigger than k, because I'm shooting off to positive infinity. I want to be less than negative k, because if I'm on the negative side, I'm shooting off to negative infinity. So that's how I kind of remember which way I set up my inequalities. And then you can set them up however you want, or remember it however you want, but that's how I remember it. If I'm going to the positive infinity, it's the positive k, and I got to be greater, because I'm going to positive infinity. If I'm less than the negative k, because I'm shooting off the less than. So again, this is the hard one. I always find this is the hard one for myself and for students. Alright, and so that's the setup, and now we're going to just go through and do some examples, and so the next video will be solving these types.